So, introduction to slope, cycle 2, day 5. Slope is a number that represents the steepness or slant of a line. Well, you can think of slope as slope of a hill. You're either going up a hill or down a hill. It has a steep slope, or it might have a more flatter kind of slope. So, developing the formula for slope. On the grid below, find the coordinates of 2 points and label it appropriately. So on the right, I see this line. So if I picked, let's say, these 2 coordinates as my coordinates to find my slope of the line, the thing is, I can't really precisely tell what the order pair of these coordinates are. So see how it's approximately 3.8-ish? So I have to round in that case. And whenever possible, I don't want to round if I don't need to. What are some better coordinates to pick? Well, if I pick the coordinates towards the end, I would have coordinate A and coordinate B. All right, so draw a right triangle connecting points A and point B. So I usually draw these bubble arrows to keep track of how many I'm going towards the right or left. So I have a run of 4 because I went left to right by 4. I have a rise of 3 because I went up 3. Right? Determine the rise and run. So I already did that while I was doing step 2. Now label the endpoints A, x1, y1, and B, x2, y2. All right, so for point A, I have the coordinate 2, 3 and coordinate 6, 6. And I usually label it right underneath as x1, y1 or x2, y2. Why did I say point A to be x1, y1? Well, I wrote A first, so that's the only reason, and we'll explore that a little later on which one do we say is point 1 versus point 2, and does it matter? Well, what do you think? All right, determine the rise and run in terms of x1, y1, and x2 and y2. So if you notice, when we're finding the slope, we're looking at how much has my line rise and ran by, right? And we're comparing that. And so what we're actually doing is, well, if we're looking at the y values, it went up by 3. And when we're comparing the x values, we went right by 4. And so exactly what slope is we're doing rise over run. We're comparing the rise over run. And so we're doing rise divided by run. So there are different ways of formulating it. So we have rise over run. We have change in y over change in x. So how much has my y's and how much has my x changed by? Another word we can use is delta y over delta x. And delta represents change in. Okay. So I'm going to write, well, y2 minus y1 over x2 minus x1 is how I'm going to compare my y's and x. And I usually keep it at that order. All right, so I have y2 as 6 and y1 as 3, so 6 minus 3. And x2 as 6 and x1 as 2. So 6 minus 3 is 3. 6 minus 2 is 4. So my slope is 3 over 4. Does that make sense? Well, it's positive. It's going up. It's not super steep. It's about a slope of 1, but not quite. So slope is about 0.75. Slope is 3/4. Example 1. Using the formula you developed, calculate the slope between points 2, -3 and 8, 6. Prove that it doesn't matter which point x1 or which point is x1, y1 or x2, y2. Okay, so let's have scenario 1. So scenario 1 is when we have 2, -3. And I'm going to label that as x1, y1. Well, why is that? Well, 2, -3 I'm going to say is 0.1. That's my 0.1. And remember, the first part of the order pair is the x, and the second part is the y. And therefore, if that's 0.1, 8, 6 must be my 0.2. So that must be my x2. That must be my y2. All right, that's my scenario 1. Scenario 2 is I have 2 comma negative 3 and 8 comma 6. I'm gonna label that as x2, y2, and x1, y1. So do you think it's gonna make a difference me labeling 2 comma negative 3 as 0.1, and then in a different scenario labeling 2 comma negative 3 as 0.2? Well, we're gonna see. All right, so m is equal to y2 minus y1 over x2 minus x1. And I'm gonna plug in my values. And I usually write this all out. For my coordinates, I distinguish what my x1 and y1 is. And therefore, when I sub things in, it's very clear what I need to sub in. So my y2 is 6, my y1 is negative 3, so I have to copy and paste that minus, and I have to copy and paste that minus in front of the 3, and then x2 is 8, and then like that. So 6 minus 3, well, that's 6 plus 3. 8 minus 2 is 6. Use arrows to keep it organized. 6 plus 3 is 9 over 6. Is that the final answer? No, you got to reduce. So m is equal to 3 over 2. All right. Scenario 2. Going to write my formula again. M equals y2 minus y1 over x2 minus x1. So with the formula, I keep it consistent. I don't change the orders of my formula. All right, I'm going to plug things in. This time, my y2 is negative 3. My y1 is 6, so minus 6 all over. X2 is 2 minus 8. Negative 3 minus 6 is negative 9. 2 minus 8 is negative 6. So that is equal to 3 over 2. So m is equal to 3 over 2 again. So reason that is we are just kind of looking at the two coordinates, but in different angles. Okay, so therefore, I have the same answer regardless of whether I look at 2 comma negative 3 as 0.1 or 0.2. And why that works has to do with kind of the way you're looking at it. So if you look at the previous example where we got m equals 3 over 4, we're looking at it from point A to point B, right? But if you're looking at it from a different perspective, you can look at it from point B to point A. And so you're really going run of negative 4, and then you're going down, so the rise is negative 3, and slope is equal to rise over run. Therefore, rise is negative 3, run is negative 4, and therefore slope is 3 over 4. So as you notice, the slope is the same regardless of how you look at it. And so that's why the comparison between two coordinates in different ways work both ways.